Okay, hi everyone, and welcome to another seminar of the Computational Humanities Research Group at the Department of Digital Humanities of King's College, London. My name is Barbara McGillivray, and today I am very pleased to introduce Yiqin Zhang, who's PhD candidate in Information Management at Nanjing University and a visiting researcher in Digital Humanities at King's College, London. Her research focuses on applying NLP and pre-trained language models to historical Chinese texts, with an emphasis on methodological reflection and practical DH workflows. She has published multiple studies in Chinese DH and information science journals on text annotation and semantic analysis of classical Chinese corpora. And today, she's going to talk about working with pre-trained language models in digital humanities, experiences from classical Chinese text analysis.
Okay. Can anyone hear? Is it working? I
Yes.
okay, thank you. And good afternoon, everyone. I'm really honored to be here to share some my research experience with you. And today I would like to share some experience from my research on applying pre-trained language models to classical Chinese texts. These talks bring together several projects that I have worked on over the past few years, and the project focuses on building computational infrastructure for classical Chinese text analysis and exploring how these tools can support digital humanities research. Rather than presenting a single technical contribution, I will describe a broader research trajectory from building dataset and language models to applying them in humanity research, and finally reflecting on how new generative AI tools can changing the research landscape. Okay, and the first we have a brief outline of the structure of the whole talk. First, I will introduce the background and focusing on why classical Chinese texts pose particularly data challenges. And second, I will describe the overview project, and then I will present the NLP pipeline, particularly in Chinese NLP, and including some segmentation, part of speech tagging, then entity recognition, and related tasks. And fourth, I will show a case study where we apply these computational tools to across linguistic stylistic analysis of the text. Finally, I will discuss some LLM transition and the reflections. Okay, for the background, I would like to introduce why promoting cross cultural understanding is important, as it's an important goal of the global cultural exchange. Historically, many Western literacy and philosophical works have been translated into Chinese, and for example, like novels, poetry collections, and philosophical writings from Europe and some North American have been widely introduced into Chinese scholarship. However, the reverse direction of cultural transmission is still relatively limited. So many classical Chinese texts remain difficult to access for international scholars due to the language barriers and the lack of the computational tools for processing this text. So therefore, improving the international accessibility of the classical Chinese literature has become an important research question. And classical Chinese literature is one of the most important carriers of Chinese cultural heritage. It represents one of the world's oldest and richest textual traditions, covering more than 2,000 years intellectual history, and this text includes historical chroniques, philosophical works, and scientific writings, and the literature compositions. So and although massive digitalized projects have already made many of the texts available online. Most of them remain digitally archived but not computationally analyzable. So this means that scholars can read them, but it's still difficult to perform large-scale computational analysis. Therefore, developing intelligent methods for processing and analyzing classical Chinese texts has become a key task for digital humanities. So why classical Chinese is computationally difficult? From a computational perspective, classical Chinese presents several major data challenges. First, classical Chinese texts are unsegmented. Unlike English, there are no space between words. And second, this is a lexical ambiguity. A single Chinese character may function as a long verb or adjective depending on the context. And third, classical Chinese grammar includes many phenomena such as word class flexibility and some ellipses, which make automatic analysis more difficult. And finally, and third, classical Chinese grammar includes many phenomena. And finally, classical Chinese differs significantly from modern Chinese in vocabulary, syntax, and semantics. As a result, NLP tools trained on modern Chinese or English usually perform poorly when applied to classical Chinese texts. So here we can have two simple example, and let's take the left string. We can see it means 南京市 长江大桥. It means Nanjing City Yangtze River Bridge or Mayor of Nanjing Jiang Daqiao. Its segmentation differs and it has different meanings. And that's the reason why we need some NLP tools specializing in classical Chinese text. And for the digital humanities and Chinese historical text, here we can see we regard the digital humanities aims to apply computational methods to traditional humanities research questions, and our goal is to transform the digitized text from simple searchable archives into structured and analyzable data. And China currently has very large digital collections of the classical texts, such as the Siku Quanshu and some Chinese text projects. However, most of them resources are still essentially digital image or pen text files. And what's still missing is a robust NLP infrastructure specially designed for classical Chinese. Here, our project is attempts to bridge this gap. Then we come to the project overview. The research presented here follows a communicates trajectory, and the first phase focuses on the corpus construction and annotation standards for classical Chinese, and the second phase is involved building domain-specific pre-trained language models such as SQL-BERT or SQL-Robot. And the third phase performs semantic benchmarking across multiple NLP tasks. And the fourth phase applies the resulting tools to humanities research questions such as stylistic analysis. And finally, we explore the use of the generative large language models for more complex information extraction tasks. Each phase builds upon on the previous one, and in other words, we begin with the technical infrastructure before moving forward towards humanities interpretation. Okay, and then we come to the corpus we use. Our main training corpus is the Siku Quanshu, one of the largest collections of classical Chinese texts. It compiled during the Qing dynasty between 1773 and 82, and the collection contains more than 3,400 titles and covers approximately 2,000 years of intellectual history. The texts are organized into four major categories like classics, history, philosophy, and literature. In total, the digital corpus we use contains roughly 500 million Chinese characters, making it one of the largest available datasets for classical Chinese language modeling. Here we have two methods we generally use. One is the fine-tuning an existing bird model, and the other one is the pre-train your own model from scratch. If it depends which method is available, it's depending on your dataset size and your specific tasks. And then we come to the NLP task pipeline. After constructing the corpus and training language models, we evaluate the models across 6 major NLP tasks. These tasks including the word segmentation, part of speech tagging, named entity recognition, automatic punctuation, keyword extraction, and the text classification. Together, the tags from the core NLP pipeline for the classical Chinese text analysis. The text one is the automatic word segmentation. Because the classical Chinese does not contain explicit word boundaries, segmentation is essential for all downstream NLP tasks. So in our approach, we fine-tuned Schoolbird using a bio LSTM CRF architecture and incorporated external dictionary feature. And our training corpus includes 6 official historical chronics from the pre-Qing dynasty to the Three Kingdom period, and the results shows that Zuckerberg achieved the best performance among the test models. And this task 2 is part of speech tagging. Here, the model assigns grammatical categories such as nouns, verb, and pronouns, and our results shows that the one overall F1 score above 91%. However, certain categories remain challenges. For example, we can see the adjective and some positional nouns have much lower accuracy. This reflects the linguistic characteristic of the classical Chinese where word classes are highly flexible. And the task 3 is the named entity recognition. The task identifies the entities such as person's name, place name, and official title. And these titles are especially important for historical research and for constructing knowledge graph from the historical text. So our experiments shows that Zuckerberg consistently outperform generally proposed models such as some bird-based, and some robotic. And the task fourth is the automatic punctuation. And another important task is making classical Chinese text originally lack the punctuation. By treating the punctuation insertion as a sequence labeling problem, we can automatically detect sentence boundaries, and this significantly improve the readable of the classical text and also support further computational analysis. And then we come to the keyword extraction. The final task includes the keywords extraction and the text classification. And the keywords extraction allows scholars to quickly identify the main sense of the text and we can know the topics about the book easily, the text classification can also automatically categorize the philosophical works into different schools of the thought, such as Confucius or military traditions. And these tasks move beyond the simple text processing towards knowledge, organization, and cultural analysis. Then we come to a case study. After building the NLP pipeline, we applied it to a humanities research questions. And in this case study, we performed a cross-lingual stylistic analysis of the historical text. The goal is to compare the stylistic features across the three linguistic versions. One is classical Chinese, another is modern Chinese translation, and the third one is English translation. And our methodology involves several steps. First, schoolbirds perform like segmentation and part of speech tagging on the classical Chinese text, and then we move to the compute the several stylistic metrics, including the part of speech distribution, the word length, and the type token ratio, and some lexical density. These metrics allow us to compare the stylistic patterns across the different languages. Here's here's is a little sample of our corpus we built, and we can see we have the classical Chinese sentence and then modern Chinese sentence and one English translation. And here's is one example of our data annotation. And we see the task as a sequence labeling, and so we give the words. This is a person's name, so the first words in this person's name we give them B label to resemble to as the beginning of the name, and then we give the end of the name is the E, and if the word is a single word, and we give the S as a single. And and this list is means the part of speech tagging, and we just put it into the BERT model, try to learn the regular behind this sequence. And we also use some baseline model like by LSTM-CRF to see the result comparing with some pre-trained models and some baseline model. Here is three versions of our part of speech tagging set. As we all know that the vocabulary between the language, even the traditional Chinese and the modern Chinese is different. So we choose three different parts of speech tagging sets for each version. And here is the result. We can see one interesting finding concerns the lexical density. The classical Chinese text shows that a classical density of around 63%, and the modern Chinese translation reduced this to about 51%, and English translation further reduced it to around 30%. And this result just aligns with the well-known linguistic theories of the translation simplification, which suggests that translated the text tend to be simplified the complex the linguistic structure. And then up to this point, our workflow allows the traditional paradigm of the pre-trained language models. This involves the training a model on a large corpus and then fine-tuning it for the specific task. However, the emergence of the generative large language models introduce a new way. And instead of the training the specializing model, the researchers can now perform many tasks only through the natural language prompting. Here we can see I just have some example of how we comparing with the pre-train model workflow to the generative LLM. And I also provide with one research. This is a nest named entity recognition with LLM. It's also from my previous research. We just applied the generative model to the nested entity recognition in intangible cultural heritage text. And for instance, we can see the phrase this means 峨眉武术. It means one kind of the Chinese kung fu. It's 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 a intangible cultural heritage, and it also contains both a location entity and a cultural heritage entity. Like the first two characters means it's from the Emei Mountain. It's a place, and the last two words means it's just a cultural heritage term. So if we just only use the bird or some other sequencing labeling tax model to recognize it, it might be difficult to recognize all the entity. So we want to test what if we use the large language models to understand the cultural influence behind the sentence. So here we can see the result. We're using the prompting engineering technicals such as chain of thought reasoning, and the large language models can identify this nested entity without additional training. And we here the chain 1, 2, and 72B. It just have the highest F1 score in this experiment. But however, the challenges also remain. So large language models can significantly lower the technical barrier for humanities scores, but and researchers can interact with text directly using the natural language prompts. However, these models may humiliate entity and produce inconsistent results, and sometimes impose modern conceptual frameworks into the historical text. Therefore, the role of the scholar shifts from the data annotator to critical evaluator of the model output. And we can see one important question is whether our pipeline can be applied to other historical languages. In principle, the workflow we developed from the corpus construction to the domain-specific pre-trained model and interpretation can be transferred to some other no-resource languages, like some local minority languages or some Latin or other historical text traditions. And the role of the scholar is also evolving. In the pre-LLM era, scholars rely heavily on the technical collaborator to build some computational models, and in the post-LLM era, the scholars can interact directly with AI systems. However, this does not eliminate the need of the experts, and instead, critical digital literacy becomes even more important. And to summarize, this research makes several contributes. We develop domain-specific portrait models for classical Chinese as the school bird and school robota. We evaluate them across 6 NLP tasks like segmentation, automatically punctuation and keyword extraction, and so on. And we apply the resulting pipeline to cross-lingual stylistic analysis, and we explore the use of the generative AI for complex information extraction tasks like the last entity recognition. And we want to, we also have some further directions to using some hybrid architecture to combining the BERT stability with the LLM flexibility. And we also want to expanding it to more text generally, not only focus on one dynasty or one time period or some other languages. And thank you very much for your attention. I would be very happy to discuss any questions or comments you may have. Thank you.